Good morning all of you. Straight lines part 4. This part we will learn how to write parallel equations of straight lines and perpendicular equations of straight lines. So this is kind of application you can say or theories. So parallelism and perpendicularity. So you can see for parallelism means two lines are parallel. So if two lines are parallel, they will have the same slope. Why so? Because of same corresponding angles which is being created with the x-axis. So here what we write, m1 will be equal to m2. Okay. So this is the parallelism concept. Now if we try to write the perpendicularity, we see that m1 and m2, m1 means the slope of this line is m1 and slope of the line which is parallel to it is m2. So this is m1. So the relation will be m1 m2 equals to -1. So how this can be proved? This can be proved from the angle between the two straight lines, because you see what happens here, tan theta becomes tan pi by 2, which is undefined. That means division by 0. So 1 plus m1 m2 is equal to 0. So m1 m2 becomes -1. And as well as this, when these two are equal, so m1 and m2, how they are equal? Because no angles are created between them. So tan 0 is equal to 0. So m1 is equal to m2. So this is how we get. So proof of this two is actually linked with angle between two straight lines. That's why we are doing this. Now say how to write a parallel equation. Say I'll take an example. Say a given line, say 2x plus 3y is equal to 10. Okay, so this is the line equation given. So any line parallel to 1 means this is 1. Say this is 1. Will be in the form of, so how to write this? You retain the same coefficient first of all. So 2x and 3y, you retain the same coefficient. Only the constant you put another something like C1. Okay. Now why this happens? Because there could be many. So 2x plus 3y, let's say this is 2x plus 3y. Okay. Say this is 2x plus 3y equals to 10. So there could be many parallel lines to this. So actually this C1 can vary. C1 is some real number. So it may vary and produce many equations of straight lines. So that's why we can write like this. Now coming to perpendicularity. So the same equation if we take, so any line perpendicular, okay, to 1 will be, first what we do, we interchange, we swap the coefficients. Say we will write 3x and 2y. Okay. And if there is same sign that they both are plus, say this is plus 2 and this is plus 3. So we will put one sign different. Okay. So we will put a minus. Either minus 3x plus 2y, or we can write 3x minus 2y equals to something like C2. Why? Again the same concept. If this line is this, there could be many perpendicular lines. So this C2 will vary and create the equation of many perpendicular lines. Another example, if I take, say example 2, this is example 1. Say something like, I'll take a different thing like say 5x plus, so 5x minus 2y equals to 1. So a line which is perpendicular to this will be, first of all swap it, 2x and 5y, and what we observe, different sign. Why? This is plus 5, this is minus 2. So if different signs are there, so we put the same sign over here. So I will write a plus. So it becomes plus 2x plus 5y. Then some constant like C3. So remember this thing, and parallel line if I want to write of this 5x minus 2y. So I will retain the same coefficient and write something like other constant. Okay. So remember this thing, if we need to write some parallel line equation of a given line, so we retain the same coefficient. But for perpendicular line, first we swap the coefficient, and if there are same signs like this, we will write different signs for x and y. And if there are different signs, we will write the same sign. So this is the perpendicularity and parallelism, and how to write parallel equations and perpendicular equations. Next we study distance of a point which is given from a straight line. That is also given. Okay. So distance from a given point from a straight line. That means, say I get a point P which is having x1 y1 coordinate, and I get a line something like ax plus by plus c equals to 0. So what will be the distance? Distance means the perpendicular distance. Okay. So if this distance is small d, so this d will be equal to, you can put this over here. So ax1 plus by1 plus c divided by root over a square plus b square. So this will be under mod. Why under mod? Because under any situation distance cannot be negative. So ax1 plus by1 plus c, and definitely this is units. So distance of a point given from a straight line. A short sum may be something like, find the distance of 2, 3 from 3x minus y equals to 5. Okay. So what we need to do? The distance will be, first change this. This is what? 3x minus y minus 5 equals to 0. So put 2 and 3 over here. So 3 into 2. Okay, minus 3, y value I put, minus 5 whole divided by a square plus b square. What is a, what is b? A is 3, b is minus 1. So it will be a 3 square plus minus 1 whole square. So when you get it, you will get something like, so you can put a mod because this is already positive, I think, or no, it's not positive. It will be, so 6 minus 8 by 3 square, 9 plus 1, 10, root 10. So see, it's helping us, this mod is helping us actually, minus 2 which becomes 2 by root 10. Okay, so this is units. Okay, so this is the distance of a point from a given straight line. Next we will find the distance between the parallel lines. Now the distance between two parallel straight lines given. That means say I get two straight lines. Say this straight line is something like ax plus by equals to or plus c1 equals to 0. Now you know how to write parallel lines. So this will be also ax plus by because you know same slope. So they are parallel. So ax plus by, only the constant will be different, c2 equals to 0. Okay, I think you understood. Now I want to get the distance between them. Obviously the distance between them will be the perpendicular distance. Okay, the perpendicular distance between these two. So this will be given as the difference of these two constants, c1 minus c2 by root over a square plus b square. So if you see the earlier formula, it was I wrote ax1 plus by1 plus c by root over a square plus b square. So it is almost the same. This was the distance between the point and the straight line, and the distance between, this is the distance between the given parallel straight lines. So obviously you find that this, if it is bigger, one is bigger, it has to be modded and the positive value will be taken because distance is always positive. So if you can do some sum on this, it will be find the distance between 2x plus 3y equals to 5 and 2x plus 3y equals to 8. Okay. So now, or I will give you something like a different equation, a little different equation, which will be something like, say, 4x plus 6y equals to 9. Okay. Now see, first you have to make the coefficients equal. Don't take it as 4x and 6y, because you see that it can be written as, either this can be written as 4x plus 6y equals to 10, or this can be written as 2x plus 3y equals to 9 by 2. Any one of these. That means you have to make the coefficients absolutely same. Then the distance will be the c1 minus c2, that means 10 minus 9, which is a mod, and then root over 4 square and 6 square, which will be 1 by then 36 plus 16, which is 52 under root. 52 means 2 root 13. So this is the distance.